All right, Salty and Sharp Steam 6 here. What am I looking for when I do some of my NTF pen draws, right? My mass gap, chess games, and things like that. What am I looking for in my gambits of the Arbiter make? Perfect 3x3 hash, salt hash, hashtag salt, obviously. Let's go back. I mean, we might need to go back a little bit here, the pump, the water, get some congruency going, some Bernoulli running. And then we're going to talk about this. What is this? Well, it's a little squiggly, but instead of coming connecting over between these 2 points, or let's stretch out this thing and actually make it straight, and then say between those things, we'll just do a little arc for the Feynman diagram turned on its side. Okay, chill out. I'll do. There we go. Much better. Much better. Uh, Inside of here, chill. You be there for a minute. I missed the diagram. Obviously, these two diagrams about y derivative over this and plus derivative of that give you some trig and field theory stuff because basically the same thing, ain't they? This is conventional current. This is electric flow we're talking about. We could use the same diagram for this, but this will run through, and I could probably have connected this straight to the battery or straight to the wire, but I'd had issues. And they talk about that obviously a little bit prior to the general model and doing some basic work. So we're going to have to go back and do Maxwell, Raylight, and Jeans, NTF, and mathematics again to get to here. Because they're obviously very different from each other, but in one frame. I can generally track that like that spin motion direction between this because button, a toggle, switch. Obviously, if the switch is on this side, you would say, well, what do you mean by that? Well, let's look Droid for a minute here and deal with the debugging process of changing some zeros and ones around to its spatial location on the screen. So what if it's on this line? The switch before the current. Now, does it work the same way? Does it work different? Does that have symmetry to being on the line here as a resistor or inductor for what plays through here in the circuitry design? And whether it's the type of cleanness that I want for the diagrams, because we would eventually want something that slides over, right? We want something that starts to be a little bit fuzzy, looks like diagrams, a little bit square wave over here, and something in the middle that actually will sub-base that system to say, well, if you're talking mathematically, it's a little bit better to run in square wave than a sinusoidal system, which is a little bit smoother, softer on the system, but maybe has anti-up YF over X and all this, because ones and zeros, how many of those ones and zeros can make some issues about the reasonings for phase states like that, like I said, because we want to squish it all inside of there, have it pop up in a useful way, if heat, then in a way that is beneficial to that system, or ways to hijack it in other buses and stations inside that system. And that's the introduction to Stanford physics or MIT's poverty trap to financial economics, and why induction could switch on some light bulbs that go off. And so you want to get those diagrams in the same way. The chemistry works that way. Why you want the basic models to kind of correlate some basic alphabet A, B, and C, a brick, one of them mother boxes, right? Get them around. The reality is, if we let you in, what is it, the Smithsonian, and actually let you touch the first Bell computer, you know what I mean? What are they doing? Some kid that knows how to crack a Game Boy would. And that's trouble. That's trouble for anybody in there that doesn't know how to do that right. Or at least get some of that basic conceptual model for the field theory down. OP brief or whatever you're doing. Now,